In this lesson, we're going to add, subtract, and multiply polynomials. And we're going to do it in a couple of different formats. This first format, we're going to do it by horizontally lining up our polynomials. So we're going to add together 4x cubed plus 4x squared minus 3x plus 10 and negative x cubed minus 2x squared minus 4x minus 4. So I've lined up the polynomials horizontally. So this would be my first polynomial, and this would be my second. Note, you don't need to have the parentheses. I'm just doing that to illustrate where the two polynomials are located. And then I have my plus sign in the center. So when I do this, I'm going to combine my like terms. So any cubic function I'm going to add with another cubic function, squared with squared, and so forth, like with like. So when I do the cubic functions, or the cubic terms, monomials, I'll be left with negative x cubed. Then I'll do my squared functions, leaving me with just 2x squared. And then my regular x terms, so minus 7x, and then my constants, so plus 6. So once we add them together, this is our sum. Negative x cubed plus 2x squared minus 7x plus 6. Our next example, the polynomials are exactly the same, but we're going to add them together using a vertical format. So we're going way back, old school, back in your elementary days when you first started adding numbers together, except we're going to do it with polynomials. It's important that you line up the like terms, otherwise this doesn't work. So I've lined up the cube functions here, and the squared functions here, and the regular x terms and the constants there. So I'm just going to then add from this point. So this will leave me with negative x cubed plus 2x squared minus 7x plus 6. And alas, I have the same answer. So we're adding them together just using a different format. Our third example, we're going to subtract two polynomials. And these are two different polynomials. Negative 4x cubed plus 6x squared plus 9x minus 3 and negative 5x cubed plus 4x minus 4. But this time we're going to do it in a vertical format. Notice that I do not have a squared term in my second polynomial. So when I set this up in a vertical format, I'm going to leave a blank here where I have the x squared. Now, if you need a placeholder, that's fine. You can just put a 0x squared if you would like. So now I'm going to subtract. But since I'm subtracting, I highly recommend that to help keep your sign straight, turn it to addition or distribute the subtraction sign all the way through. So all the signs are going to change. So that's going to be 0. That doesn't really matter. And then plus 4 becomes negative 4x, and then this becomes positive. Now I can just add them. X cubed plus 6x squared plus 5x plus 1. And that is going to be the difference between those two polynomials. Now we're going to multiply polynomials. We're going to multiply 3x squared plus 3x plus 5 with 2x plus 3, and we're going to use a horizontal format. Now this is exactly the reason why I don't like that FOIL acronym, because it doesn't work here. It's first, outside, inside, last, but that only works with a binomial and a binomial. So, if you were to multiply the first terms together, you'd multiply 2x with 3x squared, and then outside, what does that mean? We have a term, a 3x here, that we'd be totally skipping if we did that. So what we're really doing is using the distributive property. So I'm going to distribute the 2x to each of the three terms in here. So our binomial with our trinomial, I'll just say 2x with 3x squared, and that's going to become 6x cubed. Then 2x with 3x, which will give us plus 6x, and then 2x with 5, and oh, that's 6x squared, sorry, and that's going to give us plus 10x. Now I'm going to distribute the 3 to each one of the terms here. So 3 with the 3x squared, and that's going to become plus 9x squared, and then 3 with 3x, which is going to be just 9x, and then finally 3 with 5, which will give us plus 15. From this point, I'm going to simply combine my like terms. So I start with my cubed, and I don't have any other cubed functions, so I'll just bring that down. Then my squared, I have a 6x squared and a 9x squared, which will yield 15x squared. So that takes care of my squareds. And 10x with 9x gives us 19x, and then we just have the constant left over, so plus 15. And I box that in. And be sure that you write your monomials in your polynomial in descending order, with the largest degree being first. Now let's multiply the same ones together, but I'm going to show you how to do it using a vertical format. So you have to go way back when you first started learning how to multiply, and we're going to, the concept is really the same thing, just with polynomials. So when I do this, I'm going to start by multiplying the 3 with each one of these terms here, and then I'm going to write it down. So I'm going to say 3 times 5, that's going to give me 15, and then 3 times 3x, and that 15 is a plus, so I'm going to write a plus down, and then 3 times 3x, that's going to be plus 9x, and then 3x, or 3 with 3x squared, which is going to give me 9x squared. Then I'm going to do my 2x, and I'm going to multiply that with 5. Now remember, you're going to have to line these up, so you're going to have to skip what the first column, if you will. I can't really call it the ones position, the constant position, I suppose. So that'll be plus 10x. Now if you do want to put a placeholder, of course you can put plus 0 if you would like. And then 2x with 3x gives us 6x squared, and then 2x plus 3x squared gives me 6x cubed. Then we're going to add these together vertically. So I'll be left with 6x cubed plus 15x squared plus 19x plus 15. And that would be our product of our two polynomials. Now let's try multiplying 3 binomials together. In this one, we're going to be multiplying x minus 1 with x minus 1 times x plus 2. Our strategy here is to multiply the first 2 binomials together, and then once we have that, we would multiply that product with our third binomial. So let's do that. Now I can use a distributive property, but I really don't need to, because this is a special product. It's a binomial squared, so I can just do a squared minus 2ab, in this case would be 2x, and then plus b squared, so plus 1. And that I'll be left with that trinomial. And then I'm going to multiply that with the x plus 2. So now I'd use the distributive property, so I'd multiply x squared with x, leaving me with x cubed, x squared with 2, giving me plus 2x squared. Now I'll multiply the negative 2x with each of these terms in the binomial, so that's going to give me negative 2x squared, then negative 2x with 2, which would give us negative 4x. Now we do the 1, so 1 with each of these terms, it's just going to give us plus x plus 2. And then we combine our like terms. With this one, I will be left with x cubed, and then 2x squared minus x squared, they cancel out. And then negative 4x plus x gives me negative 3x, and then plus 2. And that would be my final product. Here are some special product patterns. You've seen most of these before. One is a sum and a difference, where we have a plus b times a minus b, which is equal to a squared minus b squared. When factoring, we would simply switch those around, where you would have a squared minus b squared is equal to a plus b times a minus b, and we call that a difference of squares. And that's exactly the same thing, it's just switched around. Okay, so we've seen that, we're familiar with it, we don't really need to go over that again. And there's a square of a binomial. We've seen these before as well. A squared plus 2ab plus b squared, and if it's a minus, a squared minus 2ab plus b squared. But we have not seen the cube of a binomial before. And the cube of a binomial, we have one for plus and one for minus. So instead of having a binomial and squaring it, we're going to cube it. And every time you multiply those three binomials together, or three of the same binomial, the pattern is always the same. It's going to be a cubed plus 3a squared b plus 3ab squared plus b cubed. One thing you can notice about this is, to help you remember, the first term, you're always going to start off cubing it. And, same as you have here. And then it descends. 3 to 2 to 1, and then 0, which it's gone. Then, for the second term, it's the opposite from left to right. So b to the 0, so it's not there, but then b to the 1, b squared, and then b cubed. So the first one's descending, and the second term is ascending. And the coefficients follow a pattern as well, where it's just 1, 3, 3, 1. Just think of the 3's as the same as the cube. Okay, so you have two flavors of this. You have one for addition and one for subtraction. The difference in the subtraction is our signs. The middle is always going to be positive, and then these are always going to match, the outside ones are always going to match what you have in here. So here's a couple examples. We can see where I have x squared, or x plus 2 cubed, so x cubed, and then squared, and then x, and then it's gone, and then a 2. Okay, well, there's 2 to the 0 is not there, and then 2 squared, and then you multiply that with 3, 2, and then multiply 3, and then 2 squared, multiply that with 3, and then 2. And then we do the same thing here. But I think it'd be a lot easier if we actually worked one out, and we can see that a little bit better. So I want to find the product. Now again, I could write this out and I could say, oh, 2x minus 3 times 2x minus 3 and 2x minus 3, and then we could distribute and multiply it together like we did in the last example. However, it's more time efficient to use the special product, plus you need to recognize the special product in certain cases where we use this. So I'm going to go ahead, I'm going to do this a step at a time for this first one. So remember, the first one's going to be cubed, so it's going to be 2x, and then it's going to be cubed, and then the second term is not going to be there. Okay, it's 3 to the 0, so it's not going to be there, and then we're going to have a minus sign, and then we're going to have a coefficient of 3, and then it's going to be 2x, and then that descends. The degree goes from 3 to 2, and now the 3 shows up, so 3 to the first, and then this is always going to be plus, and then our coefficient of 3 again, and then we're going to have 2x, but now it goes from 3 to 2 to 1, and then here we go from 0 to 1 and then to 2, so it's going to be 3 squared. And then finally we'll have a minus sign, a coefficient of 1. Then it's going to be 2 to the 0, so that's not going to be there. And then 3 to the third power, 3 cubed. And now we'll go ahead and simplify this. So 2 cubed, that's going to give us 8x cubed minus, and 3 times 3 is 9, and 2x squared, that's going to give us 4x squared, plus, okay, so 3 squared is going to be 9, and then 9 times 3 is 27, so I'll have 27 times 2x minus 3 cubed, which is going to be 27. And then we'll continue. So then we'll have 9 times 4, which is 36x squared, plus 54x minus 27. And that is our final product. With practice, it gets easier and easier, and you can do it faster and faster. But you just kind of have to drill this sort of thing, and then it comes fairly naturally. Okay, so that's it. That's how we add, subtract, and multiply polynomials. So I'll see you on the flip side.